Hi everyone, this video will show you how you can use MDT data and antenna projections for antenna tilting. So here is the site and the antenna you might want to tilt. And here below you have the RSRP from that cell, and it's decreasing as you go away from the site. Adjacent cells RSRP normally increasing as you go away from the site. The first thing to do is to collect MDT radio measurements with information from the cell you want to tilt. We put those measurements on the map, categorized with the following colors. Purple, the locations where the cell is serving without interference. By the way, the colors here always match the case or this chart here below. And then the blue for cell where the cell is serving but with some interference. Yellow, scattered or poor dominance. Red, that's the area where the cell we want to tilt is interfering other surrounding cells. And then orange, where the cell is measured but not so strong anymore. So how can we then use this information? You would want to optimize the antenna so that interference is minimized. So tilt the antenna so that it doesn't radiate power to the red and orange areas. We also want to maximize power in the areas where that particular antenna power is needed, so purple and blue areas, because this is the area where those customers are who need the power from that cell. So optimally it would look like this. We tilt the cell, RSRP increases here, and interfering RSRP decreases in these areas. So this is how you would want to visualize your MDT data. It shows you the areas where the antenna should be pointing and where it shouldn't be pointing. Should you then down tilt the antenna or not? Well, there are two things to consider. First one is, where is your antenna pointing now, and where would it be pointing with different antenna tilts? Here the green area represents ground and building heights together. There is a flat pot here and a small hill. We add the site and the antenna main lobe onto the picture. What we will then do is we will project the antenna main lobe onto that platform. And then it looks like this. So the purple area here is the main lobe projected on the ground. And when we tilt the antenna, the projection will change. Down tilt and up tilt. So this kind of visualization will show you where the antenna main lobe is radiating its power. Now let's have a look how it works on a map. So here we have the map, we turn it, and we place the site on the map. And by the way, this is a real-life case with real data. However, it's an illustration of the concept, and therefore the dimensions are a bit unrealistic. Now we lay the MDT measurement locations on the map using the same colors as previously explained. Here's the dominance area, and here is interference. How can we then plan and decide what would be the right tilt value for this cell? Well, we can plan the right tilt value using antenna projections. So here is the antenna main lobe. We project the antenna main lobe onto the map. So the main lobe shoots its radio power more or less in this area. And in this case, the cell service area or dominance area, however you want to call it, gets its power mainly from the antenna vertical side lobes. Antenna main lobe creating quite a lot of interference. Now let's plan the new tilt value for this cell. So we visualize different tilt values for the antenna. So you see the projection is changing as we tilt the antenna. We can also move it upwards. So this is a special software which can do this. I would probably select this tilt value for this antenna, because then most of the power would be radiated to the area where the customers are, and we could then probably decrease the interference in these areas. Now let's take a look at it more closely. How would this tilt impact the radio network? Let's imagine that we actually did the tilt. So here's the old value for the tilt, and here is the new value for the tilt. If we compare those two cases, we can see that we were able to potentially decrease interference by 20 dB on the main lobe area where we had lots of interference. If we compare the old value to the new value on the dominance area, we were able to, I would say, increase coverage by something like 10 to 15 dB. So it would have a massive impact on the radio. So this is now illustrating the concept. In reality, the radio planner or optimization engineer would make the final decision on the tilt. So then to conclude, here is what MDT data and antenna projection feature enables you to do. Plan antenna tilts with confidence without predictions. Improve indoor coverage in dominance areas where your customers need the power. Reduce intercell interference for improving throughput in the surrounding cells. Thank you very much.